how do we use Newton's second law to solve problems? And the answer is we're going to use the procedure. What I'm going to do is I'm going to define a set of steps that are going to allow you to use Newton's second law to solve some really difficult, complicated problems. And this procedure is the foundation of mechanical engineering, structural engineering, aeronautical engineering, just about any kind of engineering that involves, physical structures and so on. You need to know this. So if you're thinking about it, pay attention right now. Well, everybody should, because this is very cool stuff. Okay, now the best way to describe it is to do it through an example. So let's do an example. Given, suppose I've got a tug of war going on. We've got a crate on wheels, and we've got people pulling. Let's give this a mass. Mass equals 100 kilograms. Why? Because it's easy. 100 kilograms is easy. And let's say that these people are pulling with an applied force, we'll call it F1, of 500 newtons. That's about right. If you had a couple people pulling on it, 500 newtons is reasonable for this. But let's say F2 is equal to 700 newtons. And we want to find the acceleration of the object, the acceleration of this. Okay, solve. So what I'm going to do over here on this separate sheet of paper is I'm going to put the steps. You don't have to write them down right now. I'll put this piece of paper up here for you to copy down when we're done with the example. Okay, but this is the procedure. Step 1. Given, find, solve with a picture. Draw a picture of the problem. Use given, find, and solve. So I already did step 1. So when you read the book or read the problem or you're taking a test or whatever, set it up with given, find, and solve. Okay. And so there it is. So then what I'm going to do is step 2. Step 2, I'm going to draw the free body diagram. Okay, I want to know what is the acceleration of this crate. So I'm going to draw a picture of just this crate. And I'm going to draw a picture of all the forces acting on it. Gravity is pulling it down. Now, let's say it's got 4 wheels. Let's not worry about the wheels right now. Let's just combine all the force of the floor pushing up on the crate. We'll just draw it as one force. And we'll call that the normal force. The normal force is the force that the surface that it's on pushes on that crate. And again, if it has 4 wheels, there's 4 little normal forces, but they all add up to one big normal force. And we're just going to draw that one normal force to keep it simple. And then, of course, we've got F2. And we've got F1. You don't have to put the values. You already have the values of those forces in the given. So I'm not going to write the values on there. If you want to write the values on there, go for it. So what I did is I looked at the object very carefully. Listen to me now. You look at the object, the crate, and you say, what outside forces are acting on it? What from the outside world? Just imagine that crate all by itself in your imagination and say, okay, what forces are acting on that crate? Gravity's trying to pull it down, but the floor is pushing up on it. And then we've got, some people pulling it to the right, and I got some people pulling it to the left. Is there anything else? Is there any friction in this problem? No, we're going to do friction later. Is there anything, no, we're not going to deal with buoyancy forces or air pressure or anything like that. We're going to keep it simple, okay? These are all the forces that are acting on this crate. And so what I just did, I just finished step 2. Draw the free body diagram. Some places call this a force diagram, which makes a lot of sense to call it a force diagram. I am just trained and am in the habit of calling it the free body diagram, and I kind of like it because it emphasizes that, like, if you were to draw an interaction diagram, you would free one object from that diagram and just look at the forces acting on it. This is so powerful. Being able to look at an object and draw just the outside forces acting on that object. This is a big deal, being able to do that. Okay, then we're going to do the next step. And it seems kind of silly on this problem, but we get to more difficult problems, it won't be silly at all. I'm going to draw an axis system. And I identify the forces in the x and y axis. And then I look at my forces. Are there any forces that need to be broken up into their x and y components? In this case, every force lines up either with the x-axis or the y-axis. That's good. That means this problem's going to be a little bit easier to solve. But if I had a force that was, like if I had a third force that was like this up at an angle, then you would have to take that force and break it up into its x and y components. But we don't have that in this problem. We will in the next problem we do. So this is step 3. Draw your x, y axes. And then the next, I included as part of step 3. Break up forces into their x and y components. Now we're gonna, I'm gonna show you how to do that on a free body diagram in the next example. Okay, but these are already all in the x and y direction, so I don't need to do that. Step 4. I'm going to sum the forces in the x direction equals ma in the x direction. I'm going to underline this. And then I'm going to do this over here. Now, it's silly to do this on this problem, but later on it's going to be critical. Sum the forces in the y direction equals ma in the y direction. So I make these nice and far apart because I'm going to do work underneath here. Then I look at the free body diagram and I let it write this equation for me. I mean, I look at it. I'm going to look in the x direction only. What are the forces acting on that crate in the x direction? Well, we've got F2 pulling in the positive x direction. So I'm going to go F2. And then, are there any others? Yes, there's F1, but notice that it's pulling in my negative x direction. So guess what I'm going to do? I'm going to put minus F1 equals MA. Then in the y direction, I'm going to look at the free body diagram in the y direction. Look at the free body diagram. What are the forces acting? Well, in the positive y direction, I've got my normal force. And in the negative y direction, I've got negative force of gravity. Equals. Now, m times a in the y direction. What is the acceleration in the y direction? What is it? It's not 9.8 meters per second squared. Why is the acceleration in the y direction not 9.8 meters per second squared? Because it's on the floor. If you make the floor disappear, if you make the normal force disappear, yes, it will fall down with 9.8 meters per second squared. But it's not, it's on a floor. It's not accelerating at all in the y direction. Do you see that? So the acceleration is 0. Look for that in your problems. What is the acceleration? If you know that it's 0, then now what is any mass times 0? What is anything times 0? 0. So now I have done step 4. And this is when we apply Newton's second law. Apply Newton's second law in the x and y direction. Now, we're not going to do anything in this class where we need to do it in the z direction. We don't do 3D problems, but you know, eventually, if you're a mechanical engineer someday, you will. Now, I'm going to write it out like this. Sum of the forces in the x direction equals ma in the x direction. Do this. Sum of the forces in the y direction equals ma in the y direction. Do this. This is telling you what to do. This allows you to write an equation that will allow you to solve the problem, or two equations that will allow you to solve the problem. Well, in this problem, let's look in the y direction because we don't really need to. This is telling us that the normal force is just equal to the weight, which is equal to m times g. I'm given the mass 100 kilograms, and we know that this is g is 9.8 newtons of force per kilogram of mass. You can use meters per second squared if you want to. And okay, this tells us that the normal force is equal to 980 newtons. Notice the kilograms cancel. Do I need to know that to solve this problem? Was I asking for the normal force? No. But I just want you to see that you can use the y direction to solve for the normal force in this kind of a problem, and you're going to need to do that. Now, let's look in the x direction. This is 700 newtons minus 500 newtons equals ma. Now, I can now solve for a. A equal, what is 700 minus 500? 200 newtons divided by the mass, which is given to be 100 kilograms. So 200 divided by 100 is 2 meters per second squared. A Newton divided by a kilogram gives you meters per second squared. So you can say, oh, my answer is A equals 2 meters per second squared. All right. Now, this is a lot of work for a very simple problem. The problems are going to be more difficult than this. So you need to follow the procedure. Oh, I forgot to put the fifth, step 5 and last one, just solve. Use your algebra skills. See, once you've written this equation out, you looked at your free body diagram and you wrote out an equation in the x direction, and you wrote out an equation in the y direction, figuring out, solving for your unknown is just a matter of using algebra. Now, later on, you're going to have to use the y information in the x direction, or the x information to figure out what's in the y direction. You're going to have to do that. Okay? But, look, trust me, folks. If you try to do the homework, I want you to have this procedure. Like, if you haven't written it down, go ahead and write it down right now. As you solve the example problems we're going to work through, and the problems in the book, and take-home test problems, whatever. And if you come up to me and you say, Mr. Lake, did I do this right? If I don't see given, find, and solve, I'm going to say, no, you didn't do step 1. Do step 1. Don't take shortcuts. Did you draw a free body diagram? If you didn't, I'm not even going to look at the rest of your solution. I'm going to say, draw the free body diagram, then come talk to me. Did you identify your x and y direction? And did you break up forces into their x and y components? If you haven't done that, I'll just say, okay, you need to do step 3. Then do step 4. And then, step 5. I promise you this, if you follow the procedure, don't take shortcuts. Follow the procedure. Take the time to do everything the way I tell you. You will be able to solve some of these very difficult problems. If you try to take shortcuts, you won't. It'll just be a mess of algebra, and I won't be able to figure out what you're doing. On the exam, if I see evidence that you are attempting to use the procedure on all these problems, you're going to get lots of partial credit, even if you get the wrong answer. If you get the wrong answer and I don't see any of this, you're not going to get any partial credit, or very, very small amount. Okay, so now we're going to go through some example problems together as a class, and as homework. That is all.